Welcome to Uncommon DevOps Wisdom by Uncommon Sense Consulting. Imagine you're a DevOps professional, managing a large-scale, complex IT infrastructure. You're using traditional configuration management tools, but you're constantly running into issues. Systems become inconsistent over time, changes cause unexpected problems, and troubleshooting becomes a nightmare. Now picture a different approach. Enter promise theory. This theory, developed by Mark Burgess, is a model of voluntary cooperation between individual autonomous actors or systems. In simple terms, it's all about making and keeping promises. It's a powerful concept that is highly relevant in the world of IT management and systems theory. You see, each component in an IT system can be seen as making a promise to perform a certain function or maintain a certain state. Promise theory provides a way to describe and analyze the behavior of the system as a whole, based on these individual promises. So, how can promise theory help you manage your IT infrastructure more effectively? The answer lies in a concept known as immutable infrastructure. Immutable infrastructure is a model of infrastructure management that treats infrastructure components as replaceable rather than updatable. Picture it as a Lego set. If a piece breaks or is misplaced, you don't mend or modify it. Instead, you bring in a brand new piece. This concept is a departure from traditional configuration management, where we used to tweak, adjust, and update existing components. However, this old approach often led to configuration drift and inconsistencies, causing problems that could ripple through the entire system. The beauty of immutable infrastructure lies in its simplicity. Each component is static, unchanging. If a change is needed, we don't tinker with the existing piece, we replace it. This approach eliminates the risk of unexpected side effects from updates and provides a more predictable and reliable system. Immutable infrastructure can make your promises specific, measurable, achievable, realistic, and time-based. Let's explore how. To make your promises smart, they need to be specific, measurable, achievable, realistic, and time-based. This is known as the SMART framework. Let's delve into each component of this framework, shall we? Specific means your goals should be clear-cut, not vague or ambiguous. In the IT world, this could be something like improving server response time by 30%. Measurable refers to the ability to quantify your goals. If you can't measure it, you can't manage it. Achievable means your goals should be within reach, given the resources and constraints you're working with. Next, realistic goals are not just achievable, but also sensible and fitting within your broader business strategy. Finally, time-based goals have a defined timeline for completion. This keeps everyone accountable and helps maintain momentum. By applying the SMART framework to your IT management practices, you can ensure your goals are structured, clear, and directly linked to your strategic objectives. With the SMART framework in mind, let's see how immutable infrastructure can help you make smarter promises. With immutable infrastructure, your promises become very specific. This is because immutability ensures clear and specific commitments. Let's consider an instance where a new version of a system component is needed. Instead of updating the existing one, a fresh instance is created. It's like building a new house rather than renovating the old one. This approach provides precision and transparency, as each component version stands on its own. This makes your promises specific and clear, reducing the chance of misunderstandings and errors. In an immutable infrastructure, the state of your system components is easily measurable. Imagine it like this. The condition of your infrastructure components is like the pages of a book, unchanging and definite. Verifying the state of these components is as simple as checking the instance running. It's like flipping to a page in a book to confirm its contents. This makes your promises easily measurable, ensuring that you can verify that they have been kept. With immutable infrastructure, your promises become achievable and realistic. Let's take a moment to understand why. In this model, each system state is predefined. This means there are no unexpected surprises during deployment. You're not adjusting on the fly or scrambling to manage unforeseen complexities. Instead, you're working with a clear, defined, and reliable framework. You're making commitments you know you can keep because the variables have been largely eliminated. This makes your promises realistic and achievable, increasing the likelihood of success. In an immutable infrastructure, deployment is time-based. This means, rather than manually updating or altering components, new instances are created, and old ones are phased out according to a preset schedule. Imagine having a system where old instances automatically make way for the new after a certain period, ensuring a fresh, up-to-date setup. It's like having a self-cleaning oven. This ensures that your promises are time-based, keeping your infrastructure up-to-date and efficient. Now, let's compare immutable infrastructure with traditional configuration management tools like Ansible and Puppet. Immutable infrastructure is a model that proposes the idea of replacing entire systems as opposed to making individual changes. This contrasts with tools like Ansible and Puppet, which are configuration management tools. These tools apply updates and changes to existing systems, essentially mutating them over time. The key difference here lies in the approach towards system change. Traditional configuration management tools take a mutable approach. They continuously tweak and adjust systems in response to changing requirements or to fix issues. This can lead to complexity and unpredictability over time. You're dealing with a moving target, and the more changes you make, the harder it becomes to manage or to predict the system's behavior. On the other hand, immutable infrastructure promotes consistency, simplicity, and reliability. It's all about replacing systems, not changing them. When a change is required, a new system is put in place, and the old one is discarded. This ensures a consistent state across your infrastructure, reducing the risk of configuration drift or unexpected behavior. However, immutable infrastructure is not without its challenges. It may require more resources and careful planning to implement effectively. It's also worth noting that while traditional tools focus on managing change, immutable infrastructure aims to avoid it. Each approach has its place depending on the specific needs and context of your project. As you can see, immutable infrastructure offers a number of advantages over traditional configuration management tools. By making your promises smart, you can manage your IT infrastructure more effectively. Now, having explored the ins and outs of the SMART framework and immutable infrastructure, let's revisit the benefits that they bring to the table. When you make specific promises with immutable infrastructure, you ensure clear and unambiguous commitments. Measurability comes into play by verifying and measuring the state of immutable components, making your IT management more accountable. Achieving realistic promises is no longer a Herculean task, as predefined system states make your goals both realistic and achievable. Time-based deployment, on the other hand, assists in managing the lifecycle and scheduling of system components, making your operations smoother and more predictable. Immutable infrastructure, when compared to traditional configuration tools, stands as a more efficient, reliable, and smarter choice. With immutable infrastructure, you can make smarter promises, leading to smarter system management, so why not give it a try?